Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the second example for the Boolean function simplification using a 4-variable K-map for a POS. So my dear students, in the lecture number 83, we had discussed the reduction rules for POS using K-map. Those rules include pair reduction, chord, octet, map rolling, overlapping, and redundant group rules. And my dear students, in the last lecture, we had discussed the 4-variable K-map solution, and before that, we had discussed 3 more examples regarding 3-variable solutions. So my dear students, when we come to our question is simplify the following Boolean function using a map, and our question is pi of 0, 1, 2, 4, 5, 7, 10, and 15. So here, the set of variables are not given, and while analyzing the max term representation, we can see that it is in between 0 and 16. That is, we have to use 4 variable, and we are considering those variables as A, B, C, and D. Thus, since we are using 4 variable, we have to use 2 raised to 4 set of cells in a K-map. That is, 2 raised to 4 is equal to 16 cell K-map is using for this solution, and 16 cell K-map can be represented as shown in this figure with 4 rows and 4 columns, and the rows represents the variable A and B, and the columns represents the variable C and D. So as per the question, our question is pi of 0, 1, 2, 4, 5, 7, 10, and 15. So what we have to do is mark the value 0 on the given set of cells. That is, we have to mark 0 on the cell 0, 1, 2, 4, 5, 7, 10, and 15. So the rest of the cell position should be marked with the value 1. And next, what we have to do is group these different cells. While analyzing this K-map, firstly we have to group these cells by applying the chord reduction rules for the cells 0, 1, 4, and 5. When applying the chord reduction, we can group the cells 0, 1, 4, and 5, and this grouping is marked in red color. Secondly, we can pair the cells 7 and 15, and this pair is marked with blue color. And thirdly, while applying the map rolling pair reduction rule for the cells 2 and 10, we can group or pair the cells 2 and 10, and this grouping is marked with the yellow color. So my dear students, this is how we are pairing or grouping or coding these different cells. Next, what you have to do is reduce these given groups. Firstly, while considering the first chord that is marked in the red color with the cell value 0, 1, 4, and 5, we can see that the row values, that is the values of A and B, are in the first row 0, 0, and in the second row 0, 1. Here we can see that the value of B is changing from 0 to 1 when we analyze the row 1 and row 2, but the value of A remains unchanged with A is equal to 0. Thus, for the final reduction, we can consider the value of A. Similarly, while analyzing the column of this code, the value of C remains unchanged with 0, and the value of D is changing from 0 to 1 in the column 1 and column 2. So we have to neglect the value of D, and we can consider the value of C. Thus, for the first chord, the reduced pair is A plus C, because the value of A is equal to 0 and the value of C is equal to D. Thus, we can consider it as A plus C, since the value of 0 means the variable itself, and the value 1 means the variable complement. When it comes to the first pair, which is marked in the blue color, the pairing is between the cell 7 and cell 15, and this lies in the row 2 and the row 3. In these rows, the value of A is changing from 0 to 1, thus we can ignore the value of A, and the unchanged variable in these rows are B is equal to 1. So we can consider B is equal to 1, that is B complement to the final reduction, and this pair lies in the third column with the CD values 1, 1. That is, we can reduce the first pair as B complement plus C complement plus D complement. The complementing is take because the value of B, C and D is 1 on these different cells, and the plus sign denotes the max term combination. When analyzing the third grouping, that is the second pair, this pair lies in the first row and fourth row and in the fourth column. When analyzing these row values, the value of A is 0 in the first row and 1 in the fourth row. Thus, the value of A can be ignored, and the value of B is 0 in the row 1 and row 4. Thus, the value of B can be considered for the final reduction. And since it lies in the fourth column, the value of C and D is 1, 0 respectively. That is, the final reduction will be B plus C complement plus D. So we had got, or we had reduced all the three different pairs or sets or groups, and thus the final POS for this given function is ANDing all these individual terms. That is, POS is equal to A plus C into B bar plus C bar plus D bar into B plus C bar plus D. So we had got the function f of a, b, c, d is equal to pi of 0, 1, 2, 4, 5, 7, 10, 15, which can be reduced as POS is equal to a plus c into b bar plus c bar plus d bar into b plus c bar plus d. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, simplify the following Boolean function using 4-variable K-map, and the function is f of d, e, f, g is equal to pi of 0, 1, 4, 5, 8, 9, 12, 13 and 15. So my dear students, in the upcoming lecture we will discuss the third example for the Boolean function simplification using 4-variable K-map for the POS. So see you soon. Until then, goodbye. Thank you and all the best.